So here is our example number 2, and let's see how we can solve it. It's saying that the figure below shows a layer of liquid. The liquid here, it is confined between two transparent plates, X and Y. Of refractive indices, that is given as that for X and for Y. Respectively, a ray of monochromatic light making an angle of 40 here with the normal between the media X and Y refracted through 50 by the liquid. They have shown for us the drawing here. So they're saying find the refractive index of this liquid here. So how do we get the refractive index of the liquid? We can say applying Snell's law at a point maybe A. And now if I'm applying Snell's law there, that means that I'll say refractive index of X, sine of angle in it, and then refractive index of liquid, sine of angle in the liquid as R. But refractive index here is 1.54, and then sine I, the angle is 40. And then refractive index of the liquid, sine of angle in the liquid is 50. So that means that my NLR is equivalent to 1.54 sine 40 out of sine 50. Therefore, you can pick your calculator there and press. That will basically be 1.54 times sine 40 divided by sine 50. That is 1.2922. But we can say therefore the refractive index of liquid is 1.3. We can conclude as 1.3. That is for Roman 1. And then for Roman 2, they're saying that the angle of refraction in media Y. What is the angle of refraction in media Y? And that is this one. This could be the angle of refraction. Therefore, we shall applying Snell's law at B, and that will tell us that we have refractive index of liquid, sine of I in the liquid should be equaling to refractive index of media Y, sine of R, and that will tell us refractive index is 1.3 sine I. We are in the liquid here. So we are saying that this angle here is the same as I50. So that is equivalent to 50. This angle is the same because they're alternating angle. So this 50 can also be allowed to be there. So equaling to NY. And then my NY, I have it there as 1.44. And then sine R, that is needed. So you can divide by 1.44, divide by 1.44. R is now the sine arc of 1.3 sine 50 out of 1.44. So get your calculator. Please make sure that the calculator is not in radian. 1.3 times sine of 50 divided by 1.44, and then shift sine inverse of the answer, that is 43.7 degrees or 43.8. So say therefore the angle of refraction in Y is 43.8 degrees. And then we can now attack at the last part, which is the minimum angle of incidence in Y for the ray that will not emerge from media Y. That for the ray to remain in media Y, what should be the angle behind here? So that means that we are indirectly trying to say that this ray should not emerge from it, should remain within it. That means that it should not come in this other media here, so it should remain here. In other words, you can say it should graze, it should not leave it, should not emerge away from it, it should remain within it. I mean that we look at the condition of it grazing here, so it should not come in air. And that will tell us that now, if it is emerging here, this angle here is 90. So if this is the point C, I can say applying Snell at C. Snell's at C. So there we shall say, if we are now here, we shall say, what is this angle here? This angle here will be the same, R, the R we have here. So we shall say refractive index of the glass, that is 1.44. Okay? Sine of R is 43.8. Okay? Should be equaling to, now not emerging in air, refractive index of air is 1 times sine of the angle there will be 90. So that is also equivalent to 1. I mean, here we are supposed to get R. We are supposed to get R here. Here we are supposed to calculate R back. It is this R that we need. So when we are here, we are applying Snell here. We shall say refractive index of Y, which is 1.44. And then which angle should be here? And then when this side is just grazing, refractive index of air is 1. And then sine of angle here, we are also saying the angle is 90. So what is our R? Our R equaling to, this is 1 out of, sine R is 1 out of 1.44. And that one will take us to the sine inverse. I can now rub off this part here. And then I can say my R here, R is the sine arc of 1 out of 1.44. So you can as well get your calculator and say what is the sine inverse of the answer. That is 43.98, and that is the same as 40. That is equivalent to 44. That is 44 degrees. That is, if it is now grazing here, we shall say this is 90 refractive index of air, and then this is 1.44, and then what? Sine R. Let me confirm, and then we see. Yeah, so that is our answer. And now here we are going to be working backward, please. So that means that our R here is equivalent to 44, but it is the same R here. So this same R is here because this angle is equivalent to that. So you can say applying a Snell's at B. We now apply Snell's at this point here. We shall also say, if we are moving from this liquid here, we shall say refractive index of liquid is 1.3. Now we are supposed to calculate the angle which is here, and we shall call it now sine of I is equaling to this one here. Now Y, refractive index is 1.44, and then sine of what? And then sine of 44. So what is my I? My I is the sine inverse of 1.44 sine 44 out of 1.3. And then you can as well get your calculator and say 1.44 times your sine 44, and then divide by 1.3, and then shift sine inverse of your answer. Okay? divided by, that is 50.3. Is 50.3. And then finally we can apply Snell's law. Snell's at this point here, A. So if we are now here, we have now gotten that this angle here should be 50.3. Isn't it? That means this one is also 50.3 because we are working backward. So if I'm applying at A, I'll say 1.54 sine of the angle that should now be here, I, should be equaling to refractive index of the liquid 1.3, and then sine of the angle here we have as 50.3, and then I is the sine inverse of 1.3 sine 50.3 divided by 1.54. And then you can say 1.3 times the sine 50.3, and then divide by 1.54. We are getting that, and then shift sine inverse of the answer. Please let me press again and say sine of 50.3. I'm getting that, and then divide by 1.54, that, and then shift sine inverse of our answer, and that is 40.5. I equaling to 40.5. So you can now make conclusion that for this ray here not to come out, the angle that should be up here should be 40.5. The whole idea was supposed to be working backward, that if it is not moving out of Y, that means it should graze, shouldn't come in this other media. So you start now working backward to get the angle behind. Okay? If I have this 90, I have air, I can get the angle behind. If I have this angle the same as this, now I use this angle to get the angle here. If I get this angle the same as that, so I use this angle to get what is behind, and that will be the minimum angle. Therefore, you can say the minimum angle required is 40.3.